All right, this is Mr. Schweitzer. We got a quiz here. Going to go over some answers, different ways we can do things. This quiz was out of 10 points. First one, sample of gas, 15 degrees Celsius, one atmosphere, has a volume of 2.58 liters. What will be the volume of the gas occupied at 38 degrees Celsius and 1 atm? So we have a combined gas law problem. Number one is a P1V1 over T1 equals P2V2 over T2. In this case, the volume is going to change. The temperature is changing. Looks like the pressure is staying constant at 1. So you could neglect pressure out of this guy or just put 1 on both sides. So V1 is going to be, the volume 1 is going to 2.58 liters. And we're looking at a temperature of 15 degrees Celsius. Now, most people did not make this mistake, but you have to convert this over to Kelvin. 288. And then equals, okay, then we got the volume 2 is what I'm looking for. And then looking at 38, 273 plus 38. 311. At this point, conceptually, we should realize we're getting warmer. Particles moving faster, therefore the volume should expand. And it does expand to a new volume of, if you do this math, .79 liters. Okay, next question. You can segment off your answers. A sample of hydrogen gas, H2, has a volume of 8.56 liters at 0 Celsius and a pressure of 1.5 atmospheres. Calculate the moles of H2 present. Since we're dealing with moles, we're looking at P, V equals nRT. I'm looking for moles. P, V over RT equals N. Alright, the pressure is saying that I'm at 1.5 atmospheres, so 1.5 atms. The volume is given at 8.6 liters, 8.56 if you want to be exact there. R, since I'm doing atmospheres, is 0.0821, and the temperature is given at 0 degrees Celsius, 273 Kelvin. And this mass should give you about 0.57 moles. Now, one thing you want to be aware of is that we're not at STP. So we're not at STP, but we're not really that far. I mean, we're at 0 Celsius, but we have a slightly higher pressure here, so we're close. And 1 mole of any gas equals 22.4 liters. So we have about about a little more than half a mole here, but we also have a proportional to this guy. 11 would be, half a mole at STP. And we know that we have less, we have less than 22.4, so we know this number should be less than 1. We definitely have less than a mole. Awfully close to half a mole. So watch your numbers. If you get a weird number, every number should have some amount of sense to it. A sample of dye-boring gas B2H5, a substance that is burst into flames when exposed to air, has a pressure of 345 torr, a temperature of -15, and a volume of 3.48. If conditions are changed, the temperature is 36 and the pressure is 468. Will be the new volume. Right? No moles here, so we're talking about combined gas law. P1V1 over T1 equals P2V2 over T2. Now, please sub in your values. So we got 345 torr. We have a temperature here and a volume. Those are all our initial guys. So we're going to go plug it in here. We got 345 is the pressure times the volume of 3.48 over, and then -15 plus 273. equals, and then we get a new conditions of 468, which is this guy, torr, temperature of 36, so 36 plus 273, and then we're looking for the new volume. This volume, V2, should be right around 3, I do believe. Okay, I accepted answers for anywhere from 2.8 up to 3. That's pretty close. Next one. Let's see what we've got here. Alright, so copy kind of funny, but we'll get rid of that. Quicklime calcium oxide is produced by thermal decomposition of calcium carbonate. Calcium carbonate is calculate the volume of CO2. So that's the question they want. SCP for the decomposition of 1 to 2 grams of carbon dioxide. So I'd probably write my formula out here. We got CO calcium carbonate will break down into carbon dioxide, and I think they say carbon calcium oxide. And it is balanced. So 1 carbon only gives us 1 carbon. I can't get 2 here. And whatever number is here has to be here because I have 1 carbon, 1 carbon. And I can't make up any more carbons in the product side without having them in the reactant side, so those numbers have to be equal. First things first, convert this guy to moles. I have 152 grams in watt units. The molar mass of this guy, add those guys up, 100 grams per mole. So 1 mole weighs 100 grams. I have 152. That's 1.52 moles. How do I get that? Well, it's 152. Get rid of grams and go to moles. Here's the relationship right here. It's right here. So 100 grams equals 1 mole. And we get equals 1.52 moles. And it is a 1-to-1 ratio. You may not like to show that, but that on an AP exam is what they want to see. And this is 1.52 moles of calcium carbon dioxide. Okay, and at this point, because we're at STP, I'll skip Pivnert and go 1 mole equals 22.4 liters. And my answer is about 34 liters. Number 5. Number 5 has mixtures of helium and oxygen gas used in scuba diving help prevent the bends. For a particular dive, I have 46 liters of helium. So helium, I got 46 liters. The temperature is not changing for anything, so the temperature will stay constant all the time. And then it's saying 1 atm, and then I have looks like oxygen wise 12 liters, and it's also 1 atm, and then they're pumping both of these guys into a tank that's 5 liters. So V2 equals 5 liters. There's 2 ways you can solve this problem. I'm going to use combined gas law and show how to use that one. So combined gas law is P1V1 over T1 equals P2V2 over T2. Now again, our temperature will not change, so the temperature will stay at 298 on both sides. P1 is 1, the volume is 46, equals P2, which I don't know, and the V2 is 5 liters. Now this X will give me the partial pressure of just the helium, and that should be about 9.2 atmospheres. Okay, and then the other guy is going to be same thing, just same formula. So we're going to go 1 liter, or 1 atmosphere, and we got, it's saying 12 liters, and equals X 5 liters. And solving for this guy would give you about 2.4 atmospheres. Add them both together for the total pressure, 11.6 atmospheres. Alternate way, using pivnert. Maybe seem like a little bit more work, but I would take helium and I'd use pivnert. PV equals nRT, and solve for n, getting the total number of moles there. So in this case, PV over RT equals n. Okay, so we have pressure 1, we have the volume is 46, R is 0.0821, and temperature is constant but 298. It's at 25 degrees Celsius. This will give me my moles of that guy. Now, at that point, I would want to redo it, but do it with a volume of 5 liters instead. So take your moles and do it again. Solve for volume. So I want volume, I should say pressure I want to solve for. The volume's 5. Pressure equals nRT over, in this case, V. Whatever moles you plug in here, you'll get the pressure of that item. So I have my moles, just simply plug them in there with a new, only that changes, this goes to 5 liters, and you solve for that pressure. I would run this guy, get the moles of your helium. You'd also run it again, get your moles of your oxygen. Same thing. And then some people left them in moles, but you got to get it back to pressure. So then you just run it again with each piece. And that will give you the partial pressures of each of those, which should be 9.2 and 2.4. You could then add them two together for your total pressure, 11.6. Or you could simply plug the two moles together in here, combine the moles, and plug them in, and you get for your total pressure. Should get the same answer. Some people solved it both ways. And that is our quiz. Gas quiz B. And thank you very much.